Word problems involving area and simultaneous equations. You've got this. This is probably the most abstract kind of way to apply algebra, and that is when you are given a real life scenario and you have to set up your own equations. So I've put 3 bullet points down just for you to keep in mind that when you have word problems, you usually have to set up your own not only equation but sometimes a simultaneous equation. And to do this, a sketch or a table may help you. And something that you must just realize is that we tend to overcomplicate situations and we make too many equations or write down too many unknown variables. So just keep in mind that the number of unknowns, in other words, the number of variables you deal with, must be the same as the number of equations you can create. Now, how will you create these equations? By looking at the information that's given in the question. So this example says if the area of a rectangle is 15 centimeters squared. So we've been given a piece of information there. And its perimeter is 16 centimeters. There we're given another piece of information. Perhaps we can create an equation for each piece of information given. We now need to find its dimensions. What do they mean by dimensions? The length and the breadth, or the width, all right? I'm going to call these dimensions x's and y's. So there you can see my width or my breadth is an x, while the length is a y. Now let's look at the information that's been given to us. The area of a rectangle is 15 centimeters. If you look at this x and y, can we perhaps write down an equation that equals 15? Well, you know that area is length times breadth, and we've been told that length times breadth is 15. So I've gone and said 15 centimeters squared is equal to x times y, which is length times breadth. What else? Oh, over here now, and I've called that equation number 1. What else can we write down as another equation? Perhaps call it to be called equation number 2. What about the perimeter? If you added x plus y plus x plus y, you would be adding the lengths of all the sides, which will give you the perimeter. So it's 2 lengths and 2 breadths. So the perimeter is 2x plus 2y. And do we know how big the perimeter is? Yes, we equate it to 16. What do you know? We have an x and a y to solve, and we have 2 equations right in front of us. So we can solve these equations simultaneously. Because I see a highest common factor in 16, 2x, and 2y, I'm going to work on that equation 2 a little bit. If you halve every single term in that equation, you can eventually make x the subject of the formula. So 16 equals 2x plus 2y. I just decided to divide every single term by 2, and you end up with 8 equals x plus y. If I leave x on the right-hand side of the equation and I take over my y to the other side, you'll see that x equals 8 minus y. Now I have something special to replace x with. X has another outfit to change into, and that is called 8 minus y. So if I look at the other equation that I haven't actually dealt with yet, 15 equals xy, instead of x, I can write what x is equal to, and that I got from working with equation number 2. So in this line, 15 equals xy, we now can replace x with 8 minus y. And why is this so special? Because now we have an equation with one variable only, which means we can solve for that variable. If you distribute your y, you see 8y minus y squared is equal to 15. And if you take everything over to the left-hand side of the equal sign, you see a trinomial. Now I'm being very naughty by skipping the factorizing process, and I'm going straight to saying that y is equal to 5 or y is equal to 3. Please, can you show your brackets when you factorize in the future? I'm just trying to save space here. So now we know y is 5 or y is 3. Now let's think. Y is 5 or y is 3. That means x will have 2 possible values as well. So let's see over there from equation 2, we could see that x is equal to 8 minus y. And now we have a very specific y value that we can substitute in that place. So when y equals 5, x equals 8 minus y, which will be 8 minus 5, which will give you 3. So if so if y is 5, your x value will be 3. And when y is 3, x will be 8 minus 3, which will give you 5. So the dimensions of this rectangle will be 5 centimeters as your length and 3 centimeters as your breadth. Easy peasy. You've got 3 little homework examples to to try. Unfortunately, you won't be receiving a full memo, so please use the back of the textbook to check your answers and then let your teacher know if you aren't coming right with the solutions, and then we will help you on an individual basis. But for now, because you're meant to be back at school, we unfortunately don't have the time to make full memos, so please just reach out if it's a problem, and we can all collaborate and share on our class group with the solutions to this exercise. Good luck and enjoy.